Okay, let's do this. One of the problems with this lecture, and by the way, this is late. I kind of wanted to. I'm looking away from the microphone. Sorry. I wanted to get this out sooner, but this week's been crazy. So I apologize for not getting it out sooner. But one of the problems with this particular, I'm directing this towards week 4, lab 3. One of the problems is I'm not sure exactly where you guys, all of you, are in SQL. I kind of thought you would, at 1303, you would have some of this stuff already. It would be like start out as a review and then get a little bit more sophisticated. But I kind of think I need to assume that you might not know what a join is, maybe. Let me adjust this mic so it's more in front of my face. So I noticed that sometimes when I kind of start to mumble like this, you can't hear as well, so I'm going to try to avoid that. Anyway, that's production stuff that you don't need to know about. So one of the things this lab makes a big deal out of is different styles of joins. Particularly, the thing is, I don't even think this is all that important, but I guess Oracle makes a big deal out of it. So it's two different, what's the words I want? Standards. There's a SQL /92, and I think what was the other one? SQL / I see 92 everywhere, and I don't see the whichever the other one is. It's in the lab. Let me pull the lab up. That means I'm pausing. I don't have to tell you that, but I'm going to anyway. So this is lab 3, and we did the first part in the video, I think, already. So at least I've done part A. Helped you do that part. I forgot that it was actually part of the. I didn't forget, but I guess I forgot that it really is with a whole part. I knew you had to do it. I do remember this, where part of the reason I showed you how to do database diagram, schema diagram, whatever it's called, was because of this part. So, because you need some way, until you get used to how the tables are structured, you want something to refer to. But the thing I was trying to remember was ANSI SQL 86 versus ANSI SQL 92. ANSI being the American National Standards Institute. What does ANSI stand for? I'm usually good with acronyms, but American National Standards Institute. Okay, I was right. All right, so yeah. Two different styles of doing queries. So you do need to know these, because you'll be asked on a test at some point. Unless I redesign the test, I'll let you know whether for sure. Like when we have the study guide for the midterm, I'll let you know if you have to know this stuff for sure. Know both of them. I might actually just cut it out. To me, it's the important thing is you guys know how to make the query. You don't have to know like a certain way, as long as you can do it. If you know the other one doesn't sort of matter, except in some very small circumstances. So anyway, before this lab, at least do both queries if you can. But what I wanted to do was show you, just like kind of go through unit 2. You could do this on your own, of course, but I like to go through it and like talk about it with you. So this starts on page 46, and let's see. I want to start pausing without telling you, but not this time. So on page 46, I'm just trying to see how it's setting it up for you. Now, I'm going to do, by convention, you should do these in all caps. I think I talked about this before. I want to do that. I'll try to do it in this video. Maybe I'll get lazy and start, but I don't really care if yours has it all uppercase or not. It's as long as it works. So that's the important thing. So this example, let's just do it this way for now, just to make sure we've got the correct tables and stuff. So this is what it's showing you is 2 different tables, and then it's going to come do a query that selects from both. So I've got something to say about that in a second. So here's what I want to say. One of the things about relational databases, which is something you cover in 1303, is they achieve better. You try to eliminate what are called anomalies, data anomalies, by the relational model. So part of the way you do that is reducing redundancy. So you don't store the same data in multiple places when you don't need to. The only redundancy you should have ideally is something called, I forget the term for it, intentional redundancy or something like that. Instrumental redundancy, I'm not sure, but but what it's referring to is foreign key. So if you'll notice foreign key values, a certain foreign key, which is the primary key from another table, right, could be stored many places in a child table. So like say doctor number 2, you have 100 patients with doctor number 2. The number 2 in the doctor assigned to doctor column will be there like 100 times, right? So that's redundancy, but it's meant, the redundancy is used to establish the relationship between the two entities. Otherwise, you want to eliminate redundancy. So the doctor's last name ideally will be in one field, in one record in the whole database. And depending, you might have some other table that's weird about doctors that might have it there too or something, but ideally you would have a doctor table in a we're talking about a doctor's office here, and that doctor's name would be in one what's the word, intersection. I was going to say the place on the road where the cars meet, the intersection of a row and a column. So a record and a field, an attribute. So say the last name would be in one place, so you can update it there. If you need to change it, if that doctor gets married or something, or goes through a legal name change or something, who knows? It's probably the bad example, but date of birth, if you ever update your date of birth, because I don't know, you were reborn or something. Getting new age here, but you get the idea. The one way that that's accomplished is, of course, you like design the database ideally that way to begin with, but and then you apply rules of normalization. So there's first normal form. I should probably do a mini lecture on normal forms because I don't know how much you know about that either. I should give you a survey at this point because I'm not sure what you know about first, second, and third normal forms. Those are the ones that are important. The fourth and fifth and voice cod and all that stuff is not that important for what we're doing, but we do want to establish sort of my goal. If I'm designing a database, is third normal forms. Sometimes you don't even get that because of such things as zip codes. People who know what I'm talking about know what I mean by that, I think. But the way you make tables normalized is through a process called decomposition, and that's when you take data that is together in one table and separate it out into two or more tables. Decomposition means, again, I think I said this, I don't know if it's this class or so many database subjects and all this semester, but composition means to place together, literally. Position, right? Comp means together, so you're placing together. Decomposition is to undo that. So if you got a bunch of data that's together in one table, sometimes it'll have redundancy in it because the example would be, again, I've taught doctors and patients. If you don't have that normalized, you would have, instead of a foreign key to the doctor, you would have the doctor's say first and last name in the patient table. Who's the doctor? Well, the first name of the doctor is Fred, and the second name is Smith, Fred Smith. And every patient who has Fred Smith will have Fred Smith throughout the patient's table, everywhere that you want to see the assigned doctor. That's your redundancy. To effect the elimination of some redundancy there, what you do is you create a doctor table and then put a reference to the doctor table. So Fred Smith is in one place in one record, and then you just have a pointer, kind of a pointer. If you think about programming, it's like a pointer, right? You have the foreign key is a pointer to the doctor table for, you can look up who doctor number 2 is. It's Fred Smith. So that's to the process of decomposition. Now, the side effect of that is that if you need data from more than one table, if say I want to print out all patients and the names of their doctors, because that's information. 2 doesn't make sense to a human being most of the time. Well, who's their doctor? 2, right? That doesn't make any sense. It's great for the database to eliminate redundancy, but it's not great for the human being who needs the information. And remember, information is data in context. It's data that's useful. 2's not useful. That's just data. But Charles Johnson has Dr. Fred Smith is useful to somebody like who's, I don't know what they're doing. They're calling them, calling up for appointments or whatever. Who knows what it is? But to make that happen, though, because this information is spread out over 2 tables, you have to put the tables back together again. and that's accomplished through joins. And I can tell you, in the wild, I've been in the wild doing database queries, and I have done queries. It wasn't necessarily on me, honestly, if this sounds weird, but I really only know from one place how it worked. It might work better in another place. It depends on the nature of the business that you're doing too, and the business rules and everything. But I know I had some queries that the join had at least, I don't know, a dozen tables in it. So it can get really hairy, but we're going to start with only 2. So what we're setting up for when you do this query right here is showing that, okay, you've got one table. It's the products table. And then there's a products type table. So if you notice this query right here, what is, and again, this is not informative. You just whoever wrote this query just happens to need to know for some reason about the primary key product that's number 3, which is Supernova. But when you get this information back, what do? You get Supernova and 2 for the product type ID. It's like a category, I guess, right? What does that mean? It doesn't mean anything to you. It doesn't mean anything to me right now, for sure. I have no idea what 2 is. I haven't looked ahead in the book. I don't even know from the book what it is. So I need to find out somehow. But that information about 2, let me just be explicit about it. Let's get rid of the where. This is selection, right? If you're talking about relational algebra, that's a selection when you add a where to it. And then we'll add this to the projection. We'll change the projection to a star. I'm just kind of refreshing you on, it's a review of terms there. I don't think they're really they're important to know for the test, but like in real life, you don't think about you don't call it projection in your head when you're doing a query, but whatever. All right, so what does this table look like? You're going to have a bunch of names of, what are these products even? Looks like either games or books. I'm not even sure. Oh, debut album. Greatest. So it's music. Okay. So it's a bunch of music, or is it a combination of things? Maybe music and books, or books about music. I have no idea. It doesn't even matter. Again, this matters to the person running this business. To us, it's just an example. So, but you get into that. So what we have is a product ID. This is probably the primary key. Let's see. Honestly, I don't have this memorized. I just clicked around till I found it. So if you go down to the objects here, you can browse and right click on things to see this. I don't see anywhere, if I'm missing it, if it's here, that it says it's the primary key in this view. Actually, it's probably one of these tabs here. I think it's somewhere in the tabs, but this, whatever, the edit table brings it up too. You can see the product key is the PK. So now I want to look at these other ones. I remember some stuff being here, maybe in the constraint, whatever. It's being slow acting anyway. Let's get back to their example. Oh, come on. The remote connection was slowing down. I have no idea. But anyway, so the product ID is the primary key. And there's probably somewhere here you can see it too. I don't know, but I'm not an Oracle guru. What I'm trying to do here is teach you about relational database queries and stuff. And later on we'll get into some Oracle specific stuff, but we don't need to worry about it now. So that's the primary key. This product type ID, it's not really it's not really we don't know what it is. We can assume from the name what it is. It looks like a category of things. And that's the question. I'm like, what are all these things? That can probably tell us, right? But I can't tell by looking at this table because I just see numbers. They're meaningless to me. Pretty much meaning. I know they're a reference to something and I can use them to find out what they refer to. But for now, they're meaningless. And this is where you need the diagram for the tables. So for the cloud database, you need to figure out what table that product ID is in. Somewhere in here you can click on it and find the foreign key as well. But then we have the name, the description, and the price. So if we want to know if we want to print out what categories all these things are in, we're going to have to involve another table. So I think the next thing to see, I forgot where I was going while I showed you the whole table, but I think it's just to show you that you can't see what product ID means from that one table. So we have to figure out a way to find that out. So if you do select star from product types, which is another table in the database, execute that query. I'm just doing the play button for these. You see these are the categories, it looks like. So remember I was saying, is that a book? Is that a video? Is that a video game? Well, now this might tell you for each one, right? So what you somehow want to do to get information that makes sense into human with a synoptic view, right? Synoptic means together. It's syn, which is Greek instead of con or com or cum Latin. It means together too. So seeing together, synoptic. The synoptic gospels are called that because it looks like they were written in such a way that you can lay them side by side and read them and it's sort of the same. That's why they're synoptic. That's Matthew, Mark, Luke. Matthew, Mark, and Luke. John's not synoptic. It's really weird. I'm not here to preach to you. I don't have any religious profession to make to you. I'm just relating lateral thinking connections, right? That's what synoptic comes from. So for a synoptic view of everything in the product table and the categories that they're in, the product types, what we need to do is create what's called a join. So let's go ahead and do that. And I'll use the example from the book exactly so you can follow along there too. Or like turn me off if I'm rambling too much for you and go directly to it. So this is a long, I forget what this, it's not a fully qualified name, but it's sort of like that idea. It's like the long name of the attribute. It's the table dot the name of the attribute. So we want the name for the product table and the product type's name. This is the projection again, just to review that thing. And then we need to make sure we involve all the tables. And sometimes the order matters, sometimes it doesn't. It depends on the nature of the query, but I'm just going to type it exactly how they got it. So we're going to start with products, comma, product types. And this is not normally how I would write a join. Just, I want to point this out right now. Later on, you'll see a different version of writing a join like this. But it's a good, like, basic way to write a join. It's probably an equi-join, and it's probably one of the SQL ANSI standards or something that we'll learn about here in a second. But anyway, so you put the two tables, comma separated, put the attributes, the fields, values we want to know are from, and then you write something that will do a selection on a subset of the tables that's not the Cartesian product, and we'll talk about what that means again. I think I might have mentioned it already, but if I haven't, I'll get to it. It's not the cross. We're going to, instead of having a simple cross join, we're going to add this where clause to create a selection of records from the two tables, but only where something is in common between them. So there's a couple of things going on here that's kind of subtle to explain. Not that subtle, but subtle enough. So you really just have one where clause, and it does perform a selection. Again, a selection gives you a subset of rows, records in your results. The first part where it says where products type ID equals product type ID. Notice it's product type ID for both, but it's the product type ID from each table. So in one, for the products table, it's a foreign key. For the product types table, it's the primary key. So we're saying only give us, in this selection of results, the rows where you have the same value for the product ID as the, well, yeah, look, I'll have to show you actually I should probably show you the cross join first, but I only show us the ones where they match. I only show the rows in the cross join that match and eliminate everything else in the cross join. A cross join, again, let me explain what it is. A cross join or a Cartesian product, or there's a couple other names for it. Cartesian comes from Descartes, has something to do with math. I forget what exactly it was, the math thing that he said that this is based on, but it's somewhat probably related to Cartesian plane, right? Like the graph, X and Y coordinates, all that coordinate system. Anyway, I need to Google it up and add it as an addendum to this, but it's Cartesian from Descartes. So if you do a Cartesian product or cross join or Cartesian join, however you want to call it, what you get is all the rows from one table paired with every other row from the other table. That doesn't really have much meaning to you as a human being. You're just saying take all the rows in this table and match them up with every other row. So you'll have, like, say if you had 3 rows in one table and 6 in the other, you have 18 total rows in the Cartesian product. So you take I said 6 and 3, right? So if you take the first out of the 6 and match it up with each of the 3 in the other table, and then the second with each of the 3, and then the third with each of the 3, just kind of mush them together, what you'll see is that the product keys and the primary keys from each will most of the time not match, but sometimes they will match. That first where clause says we just want the ones that match. And the point to that is that we're only getting the records that are related to each other. I hope that makes sense. And you'll see in the results when you're running, like, why don't you just run it? Plus, we're adding in that we only want the ones from that where the product ID is equal to 3. So what this query should do, if I'm thinking correctly, let's see, prove me wrong, it'll tell you the name of product ID 3, and it'll tell you, let's see, the name, and the name of the category. So product and product type for just that one thing, for number 3 product. And as such, to me, it's not the best. Oh, shoot. Hold on. Ta-da! It's magic. I'm forever making typos. I wish there had a secretary. So what the typo was this. I left the S. Because to me, again, if you see my previous videos, I probably said this, I like for tables to have singular names, right? A noun that's singular, not plural. But it's sort of a thing that people do when they make databases, and it's really annoying. So it messed me up there, that fact. But anyway, this table is called products with an S. So that's why I got an error. I'm not infallible. So Supernova is a video. To me, for a first query in this example, I guess because they were showing you that one first and they wanted to show you, let's see what 2 means now, right? Just for that one record. I think this is a little bit more informative, but it depends on what you're doing, right? This is all the products and what category they're in. So Modern Science is a book, Chemistry is a book, Z-Files is a video, and so on. Pop3, Creative Yale's a CD, whatever. So this is information, right? You get a synoptic view of what everything is from this query. We're just getting started. This is after you use the order by clause. Notice numerals are first. Alphanumerically, numerals are first. Capital letters are before lowercase letters. So that's why in Linux, sometimes you have a README file in a directory and it's in all caps, because if everything else is lowercase, the README file will be first. ASCII capital A is 65, and ASCII capital lowercase a is 97, I think. So that's how it's done numerically by ASCII value. Anyway, numerals are lower than letters in the ASCII values. I don't know what numeral 2 is, but it's in the 20s or 30s or something. But it's lower than 65, obviously. All right, table aliases. This is a handy thing. I tend to like to do this a lot, almost anytime I'm writing a join. And so if you notice, you got products.name. That's pretty long, right? So let's try to make it a little shorter. The book, I just peeped ahead, but I feel like this is where the book's going. So I'm going to jump down past that first part of the using table aliases and go to the actual query where you use it. And here's how, when I was talking about the order selections done in, this is where I really do it. I'll jump down to products here and do P, and I'll show you why. And then product types. And this is the way a lot of DBMS SQL editor, like where you work the work thing, whatever you call it, where you write your SQL queries, will do it. It'll behave this way in SQL Server, for instance, as well. If you jump down to the from and type out the names of the tables and then the alias for the tables, once you've done that, that means you can do this. You can use that alias to help you autocomplete. If you didn't do it that way, if you did, like say for this example, this query is what? It's select p.name, comma, pt dot, it doesn't know what pt is. So to save myself from some typing problems, because I'm not the best typist in the world, I do this first. And you've already seen this, and now you have to wait for me to type it again, and I know it's annoying. And then I go back up to the select part, the projection part, right? And then I type P dot, and then hey, there's name, and then P dot. And I'm not really taking advantage of the autocomplete. I can never get used to how it's done in Oracle. I think, yeah, see, I'm not great at this. P dot, and then arrow down and hit enter. That's how you do it. Sometimes it's faster just to type it, honestly, but it depends on what it is. So it's good to know that you can do that. And I'm just in the habit of doing P dot, and then let's see, product type ID. If you can make yourself switch over to those arrow keys, it can be a little quicker. So where there's equal to PT type, product type ID. See, I'm not great at this. Arrow down, it's highlighted, there you go. And then order by P dot name. It's just easier to type it. All right, so here are the results. Now, oh, it's PT dot name. Sorry. See, when you're on stage, which I sort of am doing this, you mess things up a lot. Okay, so same thing as before, right? Except you're using aliases. Now, I kind of left this hanging, and I want to get back to it. This should be, I think this, I never do cross join, so I'm not sure about the syntax, but it looks like that's it. So let's do star, actually, because this is what you want to see. This is a cross join. This is a Cartesian product. And again, it's not, there's some, I'm trying to think, there's some cases where this is something that's useful to do, but most of the time it's not. But the way to think about this is this is the foundation. This is the cement flooring of what everything else is built on. The fact that you can put these together like this and then select certain ones, right, is how a join is constructed. So again, this is all the permutations of rows from one table and the other table, and you can sort of see it. This is the whole thing. It looks like that's the combination of two, right? So you got product ID, product type ID, name, description, and price from the products table. And then you have the product type ID and the name of the product type from the product type table, whatever the name of that table is. So and then they're just mushed together in all the combinations. So when you do a join where you say where the foreign key of one, this is the foreign key of the product table, where the foreign key of this is equal to the primary key of this, you'll only get these matches. So for instance, that's 1 and 1, and then you need to find 2 and 2. Where's 2 and 2? Is that 2 and 2? Yeah, 2 and 2. So that's what you get when you add this where clause. Now there's kind of a more elegant way of doing all this that we're going to see soon, but this is like the basic way that it works. So where the product type ID from the product table is equal to the product type ID from the product type table. So the P means product table, right? And the PT means product types table. Where those two are equal, in other words, where this is equal for this one. For this one's, this is equal to this, then you show this line. But you don't show this line. You see how they don't match one. Well, do they match? Oh, well, 2 doesn't match 1, right? And then 3 doesn't match 1. And so about 1 matches 1. So you'll get modern science. Which is a book. And it just kind of goes in order. It'd almost be great. I mean, I can do this probably. Let's do this real quick. I'm going to copy this. And I feel like this is one of the things I didn't understand about how join works. So this is why I'm harping on it, because I know there's some people maybe rolling their eyes like, I get it, I get it, I get it. And there's some people like, oh, now it makes sense. I'm hoping there's at least one of you guys. So to the one person who's like, oh, that I'll see how that makes sense now. You're welcome. Because nobody did this for me. Nobody showed me how to do these, copy these tabs either. Where did that tab go? Here's what I want to do. I want to pull that out and dock it sort of side by side. Let me put it over here. And then maybe, if it's right brain stuff, I really suck at it. So, okay, so I'm going to paste that there, and I'm going to get rid of this one, I think, because yeah, so this is the, okay. I want these side by side, so I want the one with the where and the one without the where. So this is the cross join over here on the left. Let's run it. And it probably won't be useful because we can't really make it long enough, but I think you can get the idea. You know what, we could make this useful by doing this. We'll do a projection. So we want the name of both. We want the name of both tables, because the name for the product types is the type's name, right? And the name from the products table is just the product's name. So product's name and the type, the name of the type that product is, right? That's what we're getting. So let's make it just that small in the results. Run it. So you get modern science and book, and then we'll do the same thing over here. So we want p.name and pt.name, and run this one. And honestly, you know this thing about cross, I forget it in between the last time I teach it or think about it. So here we go. But you see, there's the modern science and book. That's where they match. Chemistry and book, where it matches. Supernova, and then Z files and book. Z files is a video. I'm sorry. So these don't match. Here's what we need. This is not really useful to show you what I'm trying to show you. So you need the product ID and the type ID as well. And I know I'm not using the autocomplete, and it must be frustrating to watch. It's frustrating for me to watch, like in a Java lab or something where you don't use autocomplete on your. Yeah, in the IDE, it's really frustrating to watch you guys. Frustrating to watch you guys not. I'm talking not about all of you, but using tab complete in like the command line in Windows, and or Linux if you happen to be using Linux, or when just any kind of complete if you know it's there, or the arrow up and down in the command window for the last command. Frustrating to watch. Anyway, so see how the product ID, this is better because they're right next to each other. Product ID matches the product type ID. That's modern science. But chemistry doesn't match book. Here, it does actually, I mean, it doesn't match, I'm sorry, is it book? Chemistry is a book. Now this is not making sense to me all of a sudden. Hold on, let me see. Chemistry is product number T, and product type 2. Is modern science a book? Where's that matching at? Where the product? Oh, I'm sorry. I'm showing you the wrong thing. God, I'm not going to edit this out either. It should be the product type ID for both tables, right? That's how they're connected. That's the foreign and primary key. The product ID doesn't have anything to do with it. I swear to God sometimes. Okay, so product type ID is 1 and 1. So 1 and 1, that's the book. And you see 1 and 1 also matches, right? So chemistry is also a book. And then supernova, 2 and 1. Let's do C files. C files is product type ID 2, and product type 1 is just, again, the cross join just haphazardly, really, just it does all the permutations, so they don't match. We need to find the Z files where these two are the same. Namely where it's 2, because this first one's from the product table, so we know it's product type 2. We just need to find the name that matches over here. So we need to find 2 and then 2 for Z files. So let's go down to Z files where it says 2 and 2. And that's the one that's showing up in the results over here. I don't know if I've belabored that point, but I don't want to save the changes. But to me, the whole cross-join nature of this stuff didn't make sense the first few times I did joins. I just say, okay, I just want to make the foreign key and the prime. If it helps you to understand it, just to always remember that most of the time you do joins, not 100% of the time, but most of the time you do joins, you're trying to match the foreign key from one table to the primary key of another. You want to just say that where they're equal. That's That's the method of getting them joint, but it's based on top of that Cartesian product thing. All right, more than 2 tables. Are we ready for that yet? I want to get to these different styles, but what we're looking at right now is what's known as an equijoin. An equijoin is where you just list the tables and you have a where clause that shows where the primary key is equal to the foreign key. So use the equality operator. If you look on 51, there's a list of these. Use the equality operator. Then you have non-equijoins. Use an operator other than the equality operator. So I don't use this one a whole lot, but there are cases where you do it. And then the rest are really kind of equijoins too. So an inner join is kind of an equijoin. It's not an equijoin strictly speaking, but it has to do with when the primary keys match. So the first one, equijoins when the primary key and the foreign key matches. Non-equijoins where they don't match. It's everything but equal. It can be anything but equal. Put that on the side for a minute and then look at the last 3, inner, outer, and self joins. Except where null is concerned, these are the same as an equijoin in how they function. It's just the syntax is different. You don't use the where and you don't use the equal sign for those, but they're still based primarily on the fact that the primary key is the same as the foreign key. I'm trying to put this because they kind of say it, but they don't. I'm trying to put this in English. Like you can think of the last 3 things and the first thing. Everything but the non-equijoin are really kind of the same mechanic in a way, but not exact. There's a shade, and we'll see what the shade is with the inner and outer joins here in a minute. Aside from syntax, there's also something with null that goes on that we want to look at. We are at 36 minutes. Okay. I'm going to announce a pause. Okay, just to jump ahead a little bit, what we've been using so far is the ANSI 86 version. So in other words, the inner join stuff was introduced in 92, and that might be why. I know I learned SQL after 92. 92 was the year that I went out to the underground and planet Earth and slam danced every night. I know I wasn't learning about databases yet. We're still working on French and religious studies and anthropology at the time. Computer science came later. So I know, but I do remember my first joins were equijoins with the equal sign and the where and all that. And it was only later that I got in the habit of, my go-to is the 92 standard now. Inner joins make more sense to me, honestly. I sometimes forget how the where equal equijoin style works, but so I'm jumping ahead to 57 where they talk about that. So that's kind of basically the difference. Let's look at more than 2 tables. So let's see. Actually, you know what? Yeah, we'll do that. We'll do more than 2 tables first, and then and the non-equijoins and all that kind of stuff. But then we'll come back to the inner versus equal sign thing in this 86 versus 92. We'll come back to that before the end of this video. I hate to be all over the place, but that's just how my brain works sometimes. So let's do this one on page 50. We're going to select, enter from, and my style is to do the aliases first. So this is going to involve the customers table, which we're going to alias as C, purchases, not purchases or whatever type, purchases. And again, these are plural. I don't like that, but I'm kind of used to it, but I'm not used to it, as you saw earlier from my typo, but whatever. Products, which you've seen already, and product types table, which is we're going to call PT. And then at this point, you can jump up here and do C dot, and then you see your options. And again, what I'm doing is typing the alias and a dot, and then like sometimes a letter, sometimes it depends on how slow SQL developer is in responding with this. Then arrow down. If there's some other way to do it, I don't know what it is. I mean, if you type more, it should like move down automatically, and then you can hit, let's see, let's test that. See, see, it's not selected though. It has to be blue before you can hit enter. So I don't know. Looks like you do have to do the arrow down. I don't like my hand to go over that far, honestly. That's part of the reason I don't do it, but your mileage may vary. And again, you might find, if you find a faster way of doing it, let us know. Like, I should probably put up a forum. If I don't have a help forum already, I should probably put one up for you guys. So this is an alias for the columns. So we're saying pname as product. So it's kind of like saying the product's name, but we know it's product. And then we have pt.name. Because the reason why the person might have chosen to do these aliases for the column headings is because you got two names, two things called just name, and you want to know which name is which. So product and type when you print it out. Let me go ahead. I don't think you have to have the semicolon here in SQL Developer, but we'll add it. Let's go ahead and run this without adding any more to it. And again, this is another cross join. So it's like every combination of everything from one table with the other, except you've got times. It's a cube, right? It's customers times purchases times products times product. It's a hypercube. It's four things. So this is going to be quite long. You want to be careful sometimes when you do a cross join, because you can, like, I don't even know how many rows are in each of these. But you can see it just keeps generating. So we're up in 1,000 now. So this is when you know you've done something wrong. Usually, when you've done a cross join with 4 tables. So that's why we add the where. Now again, this right here does actually all the ands do too, because there's 4 tables. Remember, there's 4 tables to combine, so that means you need 3 clauses, I think. Let's see. Sometimes my math's bad on that aspect, but we'll see. So where the customer ID is equal to the customer ID in the PR table, whatever that is. So purchases, where the customer ID in the customer table is equal to the customer ID in the purchases table. So this is where the primary key of the customer table is equal to the foreign key, which is customer ID in the products table. Then we're going to AND that with, so this is a logical AND. All these have to be true for it to return that particular cross join row. Again, when you think about a cross join, it's going to have rows from 4 tables side by side. And we only want to return projections from, a subset of columns from those particular records where all these things we're typing right now match. So it has to be true that customer ID and foreign key and primary key are equal for those 2 tables. And then for these other 2 tables, for product ID, for the product table, for when its ID is equal to the purchase. So this is like customers are purchasing particular products that are in particular categories. So where the product type ID is equal, so this is the foreign key right here, is equal to the primary key in the product type table. So PT, I'm not looking at the book right now. I should probably do that. Okay. Where those are equal. Don't mistype. I'm kind of all sideways here, so you have to. I apologize. I'm not seeing what I'm typing, because I got the book, I got the keyboard, I've got the mic with the big pop filter in front of my face. So that's my excuse. So we got 3 clauses. Again, with 4, you're going to have. Think about it's the fence post algorithm or whatever, the fence post pattern. If you have 4 fence posts, you'll have 3 fence sections. Is that right? So between the first and I have to actually visualize it. Yeah, but if I do my 4 fingers, right, between the pinky and the ring, there's a fence slat, and then from the ring finger to the middle finger, there's a slat, and then from the middle finger to the pointer, the indicator finger, the index finger, there's a slat. So that's 3 slats between 4 posts. So that's what's going on here. You've got 4 tables, so you need 3 ways to join up those 4 tables. And the way we're doing it is, and it's again, all you really need to do is look and see what the primary keys and the foreign keys between those 2 tables that you're joining are. And that's usually what your equals are going to be. And these are the AND. So this is the first 2 fence posts connected. This is the second, and this is the third. All right. So run that, and this is what we get. 11 rows selected. I don't know. There's some error somewhere. What did I do wrong? PT product type ID is equal to P. Starting at line 5. Unknown command. Oh, did I not finish it? Where this is equal to this, and this is equal to this, and this is equal to this. Let's pause. This is what happens when you don't let it do the. You remember I was saying earlier, it's so frustrating watching guys like you not using file completion and stuff. You might have been annoyed by watching me doing that, right? Because what I did is I typed PR underscore product ID right here, and that's what caused that error. It's a good thing I can pause while I find the problem, because otherwise it's annoying. Though keep in mind, if you watch these videos, I could put these queries together pretty quickly, but when I do make errors, you're not seeing some of the debugging. So that took about 25 seconds maybe. I'm like, where is it? Oh, it's PR underscore. It should be PR dot. But what I was saying is that it's probably frustrating to see me type PR. I guess if I type this though, there's no real way to detect it. You need to do PR, the alias dot, and product ID. So try to use this as much as you can, and it'll help you not make typos. So the results it gives you are what? I think we're saying that John Brown bought the chemistry book, and Cynthia Green bought a chemistry book, and Steve White bought a chemistry book. That's what I'm assuming from the tables, just from what they're named and stuff. I'd have to look at it to be sure that's what's going on, but to me that's what it looks like. So it's saying John Brown bought the chemistry book, which is in category book. So he bought chemistry, which is in category book. And Cynthia Green bought chemistry, which is in category book. The reason why there are 4 tables here is probably because one of them is a bridge table, it's purchases. So you would have a one-to-many from customers and a one-to-many from products to that bridge table, purchases in the middle. So let's look at that. Let's verify. I'm sorry if I'm long-winded on this, but I really want to make sure we all understand what's going on. So putting this all together, you might, even if you're having trouble following, it might be good to like pause and look at it and then watch again. So what you'll notice here is that this is a bridge table. I can tell from this. This is the primary key from the products table. This is the primary key from the customers table. And the combination of these two things is going to be the composite primary key that bridges those two tables together. And it turns one many-to-many relationship into 2 one-to-manys. And what does that mean? This is just a way of saying that product 1 was bought by customer 1. Product 2 was bought by customer 1. Product 1 was bought by customer 4. We don't, because of decomposition, remember, relational databases divide all these things up so you don't have to store the name of the product with the name of the customer like many times, and the customer's name is all over the place because they buy different different products. So like we keep repeating. Instead of doing that, you just have these keys that you can look up. So when you do the join, you have to do the join to put all this back together. So if you want to know which customer bought which product, you have to involve this bridge table in between to show that. And so we're saying that customer 2 bought product 2, or vice versa. Customer 3 bought product 1. And what you should notice is that for all these, each one of these combinations occurs only once. Why? Because the 2 of these things put together, these 2 columns put together, are the primary key. It's a composite primary key. And notice you have things over here. You can have another column that with extra data, extra information, eventually, right, that tells you something about this event over here. So customer 1 bought product 1 and he bought 1 of them. Customer 1 also bought product 2, but he bought 3 of those. What you'll notice though is that this 3 and this 1 depends on both of these things together. It doesn't. This is a second normal form. 3 does not depend on only the fact that customer 1 doesn't always buy 3 things. Sometimes he buys 1. This particular time when customer 1 bought product 2, he bought 3 of them. You have to know both the customer ID and the product ID to know that 3 is what goes in that 3rd column. It's not part of the key, but it depends on both of these together at the same time, not just on one or the other. And just like to take a look at the purchases somewhere in here. Again, I'm not an expert at how Oracle's set up, but it's constraints maybe. Constraints should show foreign key stuff, but of course it times out. Oh wait, that's good. That's good actually, because it's showing you the whatever I just clicked on. Model. There we go. So it should show you that. So customers should be one to many. So it's kind of out of order. Like, can I drag this? Can I drag it? No, but I prefer this to be in between these two, but it's not. So this is one customer buys purchases many things, right? And then one product can be purchased many times. And this is the bridge table in the middle. And you can see that the product ID is a primary key. The customer ID is a primary key. I don't know why it says PF. Oh, it's also a foreign key. That's why. That's the thing about this, is the primary key from this and the primary key from this serve as foreign keys together to make a composite primary key in a bridge table. I really like bridge tables. I probably go on about them too much. I don't know why they fascinate me. They're really not that interesting, but I like to point out what's going on. I think maybe it's because I didn't understand it in the beginning. When I finally clicked, I'm like, that's cool. All right. Is that enough about a few examples? I think I went into so much detail about how those work, 2 tables and 3 tables, and how all the details of the foreign keys and primary keys work, and the cross joint or Cartesian product works, that maybe you don't need so much of these other examples. I'll let you look at them, or look at the lab that's working with a different database. Remember, it's cloud database. What I think I want to jump to is because this lab makes a big deal out about. I should talk about self joins actually, because they're neat too. Oh, do I want to? Yeah, let's talk about a self join, because I want you to see an example of a self join, and then we'll talk about the ANSI standards that are different and whatever, and what your lab's working on. So let's select. This is on page. Typing sideways again. This is on page 56. So we're going to say from. This is a classic example, by the way, where you have employees supervising or managing other employees. So this is from employees W, employees M. So I guess this is probably the W stands for worker or something, right? And then employees manager. That's the M. So we select. The thing is, what you need to see is that this is a self join, and what this means is that we're going to. You know what? Before we do that, let's do this. Select star from employees. Start there. It's always good to start with select star to look at a table, in my opinion. So what we should see here is we got an employee ID, then we have a manager ID, then we have first name, last name, title, and salary. So these are all things about the employee, and these all depend. The values of each one of these things depends on the value of the employee ID. So the primary key determines that James. Primary key determines Smith. Primary key determines CEO. Primary key also determines who the manager for that employee is. And null, what does null mean? There's no value there. What does that mean? He doesn't have a manager. He's the CEO. That makes sense. But we can't tell. Strictly speaking, we're not telling database-wise that he's the manager from the fact that he's the CEO. We're doing it from the fact that he has no manager. That's how this business rule is expressed in this database. The fact that he has no manager is expressed by the fact that he doesn't have a manager. He's the boss, right? He's null here. All these other people have managers. So this means that employee number 2, Ron Johnson, is managed by the CEO. He's managed by the CEO. The CEO manages him. Then these 2 are like underlings. So really, you've got, like, at the top, you got James Smith. You go down one level to Ron, and then it splits, and you have these 2 chumps, Fred and Susan, because they're both managed by this guy. So this is what's called a entity of unary degree. These are. I should type this out. Can I do a comment in Oracle? Do I remember how? Yeah. Unary means 1, as opposed to, say, binary. Degree. This is how many entities. Degree is a description for a relationship of how many entities are involved in the relationship. Not how many instances of each entity. So the whole one-to-many thing, this is not what we're talking about. One-to-many has to do with records or rows. Degree has to do with big rectangles. or tables. How many different tables do you have to type after the from? If you type 2, it's a binary relationship that you're working with there. If you type 3, it's a ternary. If you're doing 3 all at one time, okay, let's not get into that because that's kind of weird. A ternary relationship's not the same as having 3 tables in a join, so we'll talk about that later. But a ternary is where a ternary relationship would be, for example, you get product 1, you buy product ID 1 from vendor 3 to do something. What's the third thing? What would that be? Okay, I'll give you another example. You got doctor, patient, and treatment. So doctor 1 applies treatment 17 to patient 4. That's a ternary relationship. And how that would work in the actual implementation of the database, we probably won't even talk about it this semester, I don't think. But it's different from having 2 different relationships between those things because it's all at once, right? All 3 of those things are needed. All 3 of those tables are needed for one thing. Doctor so-and-so applies treatment so-and-so to patient so-and-so. All at the same time. That's 3 things. But a unary relationship is when somebody from one table does something to somebody else in the same table. That's really, if you want to just know the simple way of doing it, it's what you see right here. James Smith manages Ron. It's the relationship is in the same table. And notice a managing relationship can be one to many and that's the cardinality and not the degree, because one row can manage two rows at least, right, or more. All right. So the way you show like this, the fact that they have the primary key and the foreign key for the same table or in the same table, that's the unary degree relationship. The way you get the information out of that is by doing what's called a self join. So that's why we have 2 different aliases here, because we have to like refer to the columns from one with it's almost like you make a copy of the table and put them side by side and then you perform the join. So one of the tables is called W and one of the employee tables is called M, but otherwise they're just twins. They're clones, right? I hope that's just not. I'm really not. Watch this in chunks. Again, I always recommend that to students, because I know this is really going on a long, very long explanation, but it has to be done. If you use this concatenation thing that we learned from the last lab, it's really cool because you can write sentences basically. So you get column from one thing works for. I left something out. Works for a column from the other thing. So now we'll talk about this later. Don't worry about what I'm typing. I should probably just leave it out. It's a way of doing like a variable kind of expression. It's really kind of annoying, actually. I'll explain what it means here in a second, as soon as I remember how it works. But what it is it's either the last name, but in the case where the last name is null, where the value of the last name is null. Is that right? It's either the last name. Okay, it's either the last name or I have to look at here for a second. Or when last name works for, yeah. So when the last name is null, which is going to be the case when you get the primary key matching a null, right? When you see that null for manager, when the manager's null, it's going to substitute the shareholders. So the CEO works for the shareholders. Otherwise, you put the manager's last name. So you'll either get a match for the manager or you'll get null in the case of the CEO. When you get the CEO as your match on your equijoin, it'll put the shareholders. When you get anybody else where the match actually does match foreign key and primary key, you're actually getting a manager. You're actually getting one of these instead. When you get one of these, you'll get the last name. But if you get null, you'll get the shareholders. That's what that MVL means. Null value, I think, is what it stands for. It's a function that we'll learn more of these later. And I don't know why they're introducing it right now. And the book talks about it probably, and I haven't even looked at what the text says, but for this example. But And I knew there would be something wrong. Let's see, what have I missed? Well, you know what it was. It was the, well, there's a couple things wrong with this, but first thought, I had employee instead of employees. Like, again, the whole singular thing. I like for it to be a singular name. It's annoying they don't do it that way, but the book examples annoy me. I'm sure you'll talk to somebody who's been doing this for years in the industry, a lot longer than I ever did it when I was working with databases, and they're like, I don't know what he's complaining about. It's fine. What we're about to do is an outer join. This is the 86 Oracle ANSI standard way of doing it. I think a left outer join. I forget which direction, but it's a right outer join actually, I think. We'll talk more about outer joins soon, but you have to do this because of the null thing. You want to include the guy who has no manager. If you didn't put this, you wouldn't include him. Let's see if there should be 3 results now. Yeah. This is how you do an outer join in Oracle. This parentheses plus sign, I hate it. I much prefer the 92 standard where you actually have inner and outer join, left and right and all that specified. But it's good to know that this exists. So, and the reason this exists is because, again, if you remember the original results, you had a null for one of them. Outer joins match either when the primary key and foreign key are the same, or it'll do a one-time match with the null, just so the null's not left out. I hope it's over an hour now. I hope that makes sense. Okay, let's talk about the next example. This is where we get into the verses for the 86 versus the 92. So let's take the example they had. I think this goes back in time to one of the original examples, and I might not go on and on about this. I might try to tie this up soon. This will just get you started. The most important thing to understand is that the inner join, when that's introduced, that's the 92, and it sort of does the same thing as the previous. So the example we've been seeing. So this is the way I usually write joins, honestly. Not what I'm typing right now, but what I'm about to type later. So this is product types, PT, where p.product type. What this does, I tried to show it earlier on one of those first examples when we were just looking at product 3, if you remember that. And I'm like, so this is like, this part of the where is really just to join the two tables together, and then the rest of the where is like the normal kind of where you're like saying this is equal to that. Like, show me all the people in Tennessee, where state equals Tennessee, right? That's a typical kind of selection you do with a where, but part of the where in the ands is sort of taken up, the energy of it is taken up by just making the join happen, which is, you see that here where it says p.product type ID is equal to pt product type ID. It should be type ID, shouldn't it? Usually they're going to have the same. They don't have to have the same names. They just have to be the primary and foreign keys. The names can be different, but they tend to be the same in these examples. I kind of like it when they're the same, but it's no like law. So this is the join we're used to. Now, you can do this the same way. I want to do a side-by-side thing here. Can I do it? Let's see if I remember how to do SQL stuff. Let's do a new worksheet on the student connection. There's probably a way to just say, hey, make these side-by-side. Float, shift left. Split, shift, float. I mean, float would do it, but it's not really what I want. Anyway, I do want you to see these side by side because that's the whole point of this exercise. So let's try to get this set up. And I apologize for not being prepared on that. I need to learn how to interact with the UI here in a smoother way. So there's probably something I can click that just splits it into two, right, without having to do all this effort. And that's the thing I need to learn. Close that. So I'm just going to paste this to start, so I might be able to save a little bit of typing. But instead of having all the, actually, from, let me just start from the beginning because I know what I'm doing. I think I'll use this as a guide to remind me, but I also want this here for you to compare. When I'm, oh, God damn it. Here we go. So if I were writing this query, this is normally what I would do. I would go select from products P, inner join, product, what is it called? Product types, PT, on, I really want to just keep typing, but I do. Most people, they'll have they'll work out a convention for a style for where they go to the next line. Sometimes it'll be on like this. They'll go down the next line because sometimes you'll have a bunch of inner joins. Again, remember the fence slats between the posts? You'll have an inner join for each one of those sometimes. So products P, inner join, product types PT, on, and this is where you do like the equijoin part of it, where P dot, try to figure out why I think it's just because I don't have anything up here. Let's do P dot name first. If there's syntax errors, sometimes it won't try to complete for you, which is annoying. On P dot, there we go. Product type ID is equal to, you still have an equal sign in here. PT dot, oh wait, I'm telling you the wrong thing actually. It's been a while since I've done this. No, this is how you do it. I feel like they could have saved some syntax here and done something more like products P, inner join, product types PT, on product type. But I guess if the two names are different, maybe you couldn't do that. But anyway, and then you see you get the same results. You should get the same results. The only difference is that this has got order by in it. So yeah. Not iter by, order by. And in this case, yeah, you do need to do P dot name if you're going to do by the name. There you go. Now you get the same results. All right, so this is 86 style. This is 92 style. That's really the only difference. So what you're going to have in your lab is you need to do this one first and then this one with this inner join style. So what does this get for you? I mean, it's just the way I learned how to do it most recently in my life. So this is what you're going to most commonly see. You're going to see this style out in the wild. So you want to get used to it. So, but if you were to do something like this and P dot product ID is equal to 3, like that original query, which is what, the star supernova? Yeah. Part of what you're getting is this. So you see how the job is separated by the names of the thing. So the join part is accomplished by inner join, literally. It's got the word join in it. But the where part that restricts you down to a certain product instead of all the products, that's still accomplished by where. So it's a separation of concerns linguistically to me. I like that part of it. This is just the join work up here. This is the actual criteria that you want on top of that join. Here, you combine the whole join work with the criterion, and it's kind of jumbled together. So I do prefer this one, even though it's a little, is it more wordy? Not really. That's the difference, okay? Okay. And then you can see using, this is what, you don't always, I'm trying to remember if SQL Server has this, because I don't remember using it. Maybe it does, and I just never used it. But this using, this is what I was saying about, I think they could save some syntax here by, just having, in this case, the thing is they have to be the same name. I haven't read that in the book yet. I don't remember reading it either. Equals what? Product type ID, yeah. To be able to do something like this, the name of the column for both the primary key in one and the foreign key in the other would have to have the same name. And I'm doing something wrong. What am I doing? Oh, this part. I swear. So instead of having the on, you have using, and then you put the name of the column that's the foreign. They do have to be, it's not just the same name, but they need to be the primary key and foreign key to do the same work, right? But it's going to work better when they're the same name and you do your stuff correctly, which I'm not doing apparently. Select PD. Using product type ID. Oh, it does have an error. Okay. Cannot have a qualifier. Using. So you do have to use one of them. You can tell I never do this part. Nope, that's not it. Hold on. I don't know what I originally typed that was wrong, but this was right. So let's try to see what it was. You can tell I'm getting tired, so I apologize for that. So what did I do? I did this. I went back to this far using, so P. I don't even know why I'm bothering trying to figure out what I did wrong, but anyway, So you see it, and you can't like use a qualifier on this part. If you just read that section of the book, and it'll make sense. I hardly ever do this, honestly. Most of the time I write a join, I do the on something equals something, even though this is nice. This is similar to what's called a natural join. All right, forget I mentioned that join for now. They have to match in everything. I'm not sure. This is not giving me the right results, so maybe they don't match in data type or something. But anyway, forget I mentioned natural join. Focus on what we're learning here. So the next thing to show you, what is their example? Let me see if it's a good one. So you have a bunch of inner joins. I want to show you outer joins, at least one or two examples of that. Let's do this one. Starting to get hungry. I don't know about you, but my book's going to close on me. This is on page 60, by the way. Try to remember to keep you up to date on what page I'm working off of for my example. What are the columns they want for this? So this is the SQL 92. Let's do that first. So p.name, comma pt.name. All right. So we got that. We got to say what it's joined on. So sometimes I'll do the on down here. It depends. There's no like real rule to it. So on, well, they're doing a using, so we'll do a using. I always do on, but we'll do a using since they're doing it in this example. And I almost don't want to show this first because I want to show something else about it. Let me copy this. And I will show it first. So let's look at the results so we can see what's going on here. And what you should see is that you get the same thing you would get for a join except one extra thing, and it's this. So what this is saying is that we're going to show all the, and remember if you go back to the cross join, it shows you all the, with the equijoin or the inner join, either one. They're both doing really the same thing. You're taking the foreign key from one table and the primary keys from the other, and you're only showing those combinations from the cross join where those two things are equal. So the foreign keys 1, the primary keys 1, show that row, that record. Foreign keys 2, primary keys 2. Well, I'm sorry, I keep saying it that way. It's not true what I'm saying. It's the foreign key is 2, but it's the primary key in the foreign key table, right, where the foreign key comes from are the same. So when they match, I guess I was kind of saying that, but anyway. So it's going to show you all those. But one thing, but what if there is no match? If there's no match, then the outer join comes into play. So it will only show once. It's saying, okay, I'm going to show you all these where they match, but I'm also going to show you this my front line. It doesn't have a match. I just kind of want you to know that. That's what the left outer join does. So the left side table is products. The right side table is product type. And we're saying that the product called my front line doesn't have a type. It doesn't have a foreign key there. So for all, if you do a left outer join, it'll tell you everything in the product table that does not have a primary key. I mean, does not have a foreign key defined for the product type. There's no match. So everything will show up at least once. Everything in the product table will show up, including the thing that does not have a match in that other table in the cross join. I hope that makes sense. So just to show this, what you should see is that you'll see a list of everything in the products table. We have to show the foreign keys too. We can't just show the name. We have to show every column. And what you should see is that for the product type ID for this thing that's got this name, you'll have null because there is no value. So there it is. There's the product type ID. There's the null. No value here. So a left outer join will show you that for this particular case. And why is it called a left outer join? Because you're showing everything in the product table, and the product table was listed on the left of this phrase. This is the right side. If you did this instead, then it will show you everything where something doesn't, what would it be not matching? Let's see if there are any. I don't even know if there are any. There it is. So so what's the information here? The information is going to show you, it's going to show you the same results as the left outer join. Let's test that real quick. Here's the left outer join. It's going to show you the same results. In other words, it's going to be 12. There's going to be 11 things where there's matches. So these up through modern science and then after my front line, all that stuff aside from my front line is going to appear in the right outer join as well. Heck, even my front line appear too. Let's see. Yeah, it won't. But so you have all the things that match, that have the primary key and foreign key that match, will all show up in both. But what's different is what shows up with the null. So what's the information here? We're seeing what the product names are, the categories for every product. So we're seeing the name of the product type and the name. So we're, classical music's a CD, right? Where they match. But what if, let me just start over. The information we get here is the category for every product, along with the category that doesn't have a product represented. So magazine, there are no magazine products currently in the products table. There are no magazines. Alternatively, for a left outer join, we're seeing what category every product is in. Again, that's the same. But we're also seeing that my front line has not been put into a category. So on the one hand, the right outer join shows us the categories that haven't got any products in them. On the other hand, literally on the left hand, the left outer join, we're seeing the products that don't have a category. Now there's something, I'm going to type it here, and this is where it blows up in my face because I can't remember the syntax in Oracle, but I'm hoping this works. It does. Thank God for once. This gives you both. This shows you the products that don't have a category assigned to them and a category that doesn't have any products if you do a full outer join. All right. I'm going to stop there. You can read. I think this is enough for you to go on. Anybody who was confused about how this works, I think if you listen closely to this video, listen and look, maybe take it in chunks, and also maybe if you get stuck, rewind and rewatch a certain part. If that doesn't help, schedule office hour. Please don't do it tomorrow. I have a doctor's appointment and nobody's scheduled yet. And I don't want to just cancel it and go through all that trouble. So I'm going to hope nobody signs up. If they do, I'm going to have to tell them I can't make it. But don't schedule it for tomorrow, which is the 12th of February. My appointment's at 12:45. I don't think I'm going to be back by 1. So, but, Monday, if you get stuck, let me know, and we can extend the due date a little bit or something. But, yeah, so... or send me an email and say, hey, I don't understand this part. Just ask me a specific question and I'll see if I can answer it. But yeah. I hope you guys have a good rest of the week. Bye-bye.